Welcome to this tutorial on hosting a Spring Boot web application using AWS. I'm going to try to keep it very simple and easy to follow while giving you hopefully somewhat of an understanding of each component that is used and needed for hosting this web application. Jumping right into it, I'm going to be using a basic Spring REST API that I prepped just for this video. The link to this repository will be posted in the video description. It just has a couple endpoints and a database and database connection properties. That way we can use AWS Beanstalk to host the API and connect to a RDS database on AWS. I have already cloned this locally, so I'm not going to do that again. But the first thing we're going to need heading over to AWS is a VPC. A VPC is a virtual private cloud. It allows you to manage resources in a specific virtual network. Just for myself, I think of it as kind of like an organizational tool, as well as you can manage all the subnets and security for that virtual network. So by default, there will be a VPC for your account already here. We're going to just leave that one. We're not going to touch it at all. We're going to make a VPC just for this tutorial. So we're going to create the VPC. You can do the VPC only and make your subnets and gateways and all those things yourselves. But for simplicity, we're going to do VPC and more. That's going to create the VPC, our subnets, the route tables, and everything else that we really need. So the name tag auto generation, this is just the prefix to everything. So we're going to call this basic API. We'll just call this basic. Yeah, we'll just call this basic for now. I'm not worried about IP version 6, tenancy, default. You don't really need to worry about this either. You can just leave this as it is or research it yourself. Number of availability zones, recommended. We're just going to stick with the recommended settings for availability zones, subnets, private, public, and all that. We're not going to go into this too much right now. And we don't need any additional tags. So once we have that, we can go ahead and create our VPC. Okay, so we can see it's creating everything, getting it ready for us. And now that we have our VPC, we can go ahead and create the relational database that will be hosting our data. So we go here to services, and then this is where we could have accessed VPC if we weren't already at the home screen. I have recently visited the RDS area, so I can click it here. If you need, you can search for anything here in the top bar. So we'll go ahead and go to the RDS service. And you'll see that I have no database instances or anything like that. And one thing I do want to mention right here before we get too far is everything that I'm doing is available on the AWS free tier. None of this will cost any money for you if you're within your first 12 months of your account. So let's go ahead and create the database. All right, we'll go ahead and click off that. Just taking 1 second here to load up the settings. So there's standard create, where you can choose a lot of your options, and easy create, where a lot of these options are done for you. I'm going to stick with standard create, just so we have full spectrum of options. The code base that I have prepped uses a MySQL server. So I'm going to just click MySQL as the engine type. We'll be using MySQL Community, as well as MySQL 8.0.28 version. And right here for templates,
we can actually set it to only allow us to touch settings that are for the free tier. So we don't accidentally, mark a setting that is going to end up charging us. Database instance identifier. This is just a name for our database instance. I'm going to call it basic Spring app. I'll call it basic Spring DB. Okay. And we need to set up a username and password for our database, for our main, for our MySQL instance. I'm going to stick with root. And I'm not worried about managing the master's credentials or auto-generating some very tight password. I'm just going to use password as my password for this tutorial. I would recommend using a better password for your own production instances if you're hosting applications or anything like that. But for now, I'm just going to use password. These credentials will be what we use to log in and instantiate everything as need be. So database instance, notice the other ones are not available because they probably are not on the free tier. So you can leave all this stuff as default, T3 micro or T2 micro, whatever it comes with. Storage type, we're going to use general SSD, 200 gigabytes. We're going to let it auto scale again because it's within the free tier. So we'll just use the range of functionalities. This is good because it's, if ever your storage needs to increase, it will automatically for you. So there's not like downtime or issues. Let it scale up to 1,000. Connectivity. So we're going to stick with don't connect to an EC2 compute resource. We can change this later as it says here. So that's no big deal. Network type, we're going to stick with IPv4 because I didn't set up IPv6 on the VPC or create a subnet for that at all. So for now, we're sticking with IPv4. Here's a very important setting. We need to choose the correct VPC because the VPC that our database is in needs to be the same VPC that our API or web application is in order for it to have the privileges, in order for the API to have the privileges to speak to this database. So we're going to select basic VPC. It'll create a subnet group directly for the database, a database subnet group. And here is another very important setting, public access. If you choose yes, there will be a public IP address assigned to the database, and you can whitelist IP addresses or other services in your AWS account to speak with this database. If you choose no, then it won't have a public IP address, and only instances and other resources inside of your VPC can connect to your database. Okay, so that's very important right there. Public, I'm not sure. I think non-public is probably better. I really am not sure exactly. I did an internship where we had databases that were unable to be accessed by the outside. So you had to come in, get access to a certain EC2 instance through the AWS portal. I imagine that this is probably the better option. So we are going to stick with that. This tutorial, I mentioned that public access is something you can use, and it does simplify it because you can then connect to your database using something like MySQL Workbench and easily instantiate data or other things like that. But a little bit more secure, we just make it so only things within our VPC can talk to it.
So here we are, VPC security group. Well, we're going to use the default one. This is actually a bit confusing. This is the default VPC security group in the basic VPC that we created. Okay. This is not the VPC security group in the default VPC. Okay. Those are two different things. So security group is the default security group in the VPC we created. So we're going to make sure that our database is in that security group. Okay. And we have no preference to our availability zones. We're not worried about certificate authority. We want password authentication. We're going to stick with port 3306. That's standard for MySQL. What else? So we'll enable enhanced monitoring just because it's free and it's fun to have all the settings possible. And for additional configuration, right? Let's give our database a name. So what did we call the instance again? We called it basic Spring DB. So that is what we're gonna call the database. Where is the name here? Sorry, here we go. So we'll call it basic Spring DB. And notice I'm using underscores instead of hyphens now because database names can't have hyphens. So everything else will kind of leave the same. Enable automatic backups, how long to keep a backup, backup windows. We have no preference. You can set this like what time of day you want it to do your backups, all that kind of stuff. I'm not going to set up log exports for now. Maintenance window as well, no preference. And then deletion protection. Protects this database from being deleted accidentally. While this option is enabled, you cannot delete the database. We're going to leave it unchecked because this is a test, but again, for a production database, you should probably have this checked. Now that is everything we need. So the AWS free tiers for 12 months, we get 20 gigabytes general purpose SSD a month. And yeah, so we have all our settings set and let's create the database. Okay. This is just taking a little second here. It should redirect us after it finishes. Okay. Now it is, we're not going to remember our passwords. Now it's instantiating. So we can just leave it. You see the status here is set to creating. You might be wondering, how are we going to instantiate our database later if we can't talk to this remotely? Well, we're going to create an EC2 instance where we will come in and talk to the database and instantiate it as needed. So for now, though, because we have that working, let's head over to AWS Beanstalk. This is where we are going to host our API or our web application, whichever one you're trying to host. We're going to go ahead and create the application. Let's give it a name, basic REST API. We'll use hyphens. Basic REST API. Okay. We'll call it Spring. Basic Spring API. And some tags we can use. Yeah, so we'll go ahead and use environment production. These tags, they really don't mean anything. They're just tags you can use to filter, through your resources. This is a production. We're going to be using the production version of this API. That'll make sense in a bit. And we'll give it an application name. And we'll just call it, basic Spring REST API. So these again don't matter. You don't need these. You can put them for whatever. This application that we're going to be hosting is using Java. We're using Coretta 17, and we can just use whatever the recommended platform version is. All right. We're going to have our Beanstalk application start off with some sample code in there. That way something is running and we can see that our Beanstalk instance is going. And so these are just the basic settings, but there's one really other important thing here. We need to make sure that this web application is in the same VPC as the database, unless the database was set to public. But we did not set ours to public, so we're going to make sure it's in the same VPC. So presets, single instance, free tier, Coretta 17. All this stuff is normal. We're going to go down to network. The environment is not part of a VPC. Now, a lot of other tutorials are a bit out of date, so that's one of the main reasons I made this. I had to find a lot of this on my own, but we need to make sure that this is in the correct VPC. It says the default VPC. We are going to use the one we created, basic VPC. Okay. We do want a public IP address associated to this, right? Because this is our web application, whether it's an API or a website with an API, this needs to be publicly accessible to the internet. And we're going to assign the two subnets that we have to it, the two public subnets. And you might be wondering what's the difference between a public and a private subnet. Well, the difference is that public subnets can communicate outwardly to the internet. So on a public subnet, my API, I gave it a public IP address so I can talk to it. And on a public subnet, it can talk back to me. That's important. For the database settings, we're going to use the private subnets because we're not outwardly talking to the internet from the database. So go ahead and save those settings. And now we come here, see we're part of a VPC. We have a public IP and we have some subnets. All right. So now we can create the application. In the background, our RDS database was creating, initiating, and all that. So now we need to head over to, so you might think that, okay, I've added the Beanstalk application to the same VPC as my database, so everything should be good now, right? Well, almost. So yes, things in the same VPC have the ability to talk to each other, but we have to whitelist that service still to be able to talk to the database. So I just went to services, EC2, and we're going to scroll down on the left side to security groups. So we can see that the API itself got a security group associated to it. The web application automatically gets a new security group, right? And so we see we have two default security groups. The one we need is the one associated to the not default VPC. We need the one associated to the VPC we created. Notice right here, these VPCs match. So we know that this is the VPC we created. An easy way to do that is we can just click on it and see this is the basic VPC. All right, so that's the one we created. So what we need to do is open up the default security group that the RDS database is a part of. We can just click it. We can see that the outbound rules allow us to talk to everybody. And the inbound rules allow all traffic within the same security group, 250B. What we need to do is add another inbound rule to allow traffic from the security group that the API uses. So let's go ahead and add another inbound rule. Add rule. We're going to be talking to it over MySQL Aurora. Here's we post it and it comes up with this dropdown. That's the security group. And yeah, now we can take in inbound traffic from things in that security group. So save rules. Beautiful. Now we have set up the permissions. Okay, so that's great. We have our RDS database. We have our Beanstalk application. We're all ready, right? And we are. So let's go ahead and open our terminal. Okay. Well, let's head into the basic Spring REST API repository and open it up in IntelliJ. Okay. So first thing I want to point out here is our properties files. So we have this main application properties file sets the Spring Active profile, and that value is taken from our POM file. We have a production profile here, which we're going to specify when we compile our jar file with Maven. And then that will give us and that'll allow us to use the production properties file when we compile the jar, so that the right sources and stuff are used. So basically we have our data source, we have the username, the password, we're using MySQL 5, and these two just basically mean if there's any difference between the database and what we have here locally, it'll update the tables as needed, adding columns and such like that. Excuse me. So on here, one of the things I didn't mention is AWS Beanstalk used by default forwards to port 5000. So we want to make sure that our server, our web application, is using port 5000. And then we're going to need to change the URL of our database. I already have it as root and password because that's what I'm using. So let's go ahead and get the link to our database. Okay. So we have our database instance here, basic Spring DB. It's available now. And this is the endpoint. Now, as I said, this is not publicly facing. So if we tried to run our application locally with production, and I can show that here, edit configuration. If I set the active profile to prod, apply. One other thing I'm noticing here is that it was doing that. Apply at 17. So if we set the active profile to prod and we tried running this, we're going to get a communications failure. You scroll up, communication link failure. And that's because we do not have access to talk to this database. Okay? And that's what we want. We want only things within the VPC to be able to talk to our API. So that's good. So let's open up the terminal here. And I'll be using Maven. So if I do Maven version, you see we're using 3.8.7, Java 17.0, Coretta 17.0. So everything matches what I am hosting on the Beanstalk server. So we're just going to go ahead and do mvn clean install. dash p prod. So that sets the Maven profile in our POM file. And then we're going to skip our tests. We're going to skip the Maven tests. And the reason we're going to do that is because the tests will fail because it will not be able to connect to the database. Okay. So we're going to go ahead and just run our tests. Okay, or not our tests, excuse me, run Maven. And that's going to give us our jar file here. Basic REST API jar. We have, there's other things in this POM file you can explore, but I basically decided the name of the jar file here. So now we have the jar of our API. And yeah, so we can head over to Beanstalk again. No, we won't open a new tab. We'll just leave it here. Okay, so the health check is okay on our API. And that's because we loaded some sample code in there. So if we just open it, we can say, congratulations, our first Elastic Beanstalk application is now running. Perfect, right? That's good. Now, why don't we go ahead and, before we upload the code, an important thing that I just remembered in the prod file here is we need to change the database name, right? We called it Basic Spring DB. That's the name of our database. So let's go ahead and Maven install that one more time. Sorry about that, to backtrack a little on you. But basically, we're trying to connect the database that we created, which is important. If you have the wrong database name, this will also fail. Okay? So let's go ahead and upload our code. Just simple as can be. We just upload the jar file. Here's, sorry, this is actually not the right place. So make sure you go to the basic REST Spring API target folder and get your jar file. We'll go ahead and open it. Basic REST API jar. Call this basic Spring API version 0.0.1. And we will go ahead and deploy that. So while that's deploying, there is something that I want to mention if we just look at the code here. So if I'm looking at the code, you can see I have two controllers. I have a user's controller, which is just a basic controller that allows you to get all users and add a new user, right? But I also have this thing called the health controller. It's at base root, and it just returns okay. So you might be wondering, like, why do I have that? Well, with a normal web application with a front end, you'd have no problems. This would just do what it should. But with an API, the way that they test is the health okay is they're going to ping your web application. And with the API, if there is no endpoint, that is just at the base URL, it will fail because it'll return 404 not found. So we want that health check endpoint just so that way we know that, hey, they were able to reach our API and they got status 200. So you see health check okay. Name hasn't updated yet, so I'll just refresh the page. Okay, basic Spring API version 0.0.1. Look at that. We are hosted. So now we can copy this link and we can test it out, right? Let's go into Postman and let me go ahead and close these. Oh, never mind. We'll just go ahead and make a new endpoint. So we're going to do a get endpoint right here to the base URL. And you can see it returns status okay because that's our health check endpoint. Right, so there we go. We have it hosted. And now we can test, is it talking to the database? We know that it connected to the database because the fact that the server started. But if we were to try to run our get users, that would fail. And the reason is the database exists, but we don't have these tables yet. These tables don't exist. So if I run, Postman on just get end users. Oh, you know what? Actually, I'm so sorry. That will work because I have it set to update the database as needed. So we had the table users in there. The table didn't exist, and it generated it for us. My mistake. So let's go ahead and try doing a post request. All right, let's try posting, adding a user. Just use currently, if we look at the user entity, there's an ID, an email, and a password. The ID is auto-generated because that's the primary key. So we only have to provide an email and a password to create a new user. I apologize about my dogs if you hear them in the background. So we'll go ahead and try adding a new user now. We got status 200, okay. And we can go back and try getting all users. And there we go. User 1. And, oh, you know what? This had email as null because I accidentally passed it a name. So we'll go ahead and send test2 here, add this user, get users. And there we go. So we have our first user, which didn't have an email provided, but it did have a password. User 2, which had an email provided and a password. I'm sure you're wondering, why do these passwords look like this? That's because in this basic API, I did add the logic to bcrypt hash the passwords. So that's there. So you could take this and expand on it to make JWT token authentication and things like that as needed. But yeah, now we have it. Our Java Spring REST web application is hosted on AWS. It is hosted using Elastic Beanstalk. It is talking to an RDS database, all within a VPC. And if you ever needed to go in and change the database manually, what you would do is create an EC2 instance. You would create an EC2 instance as part of the VPC and add it to the RDS's security group. And then you could just SSH to that EC2 and change the database as needed. But you shouldn't really ever have to do that as long as your server is set up in a way that it kind of handles itself. And yeah, that's it. Hopefully that was helpful. Hopefully it was clear, concise. And if you have questions, please comment them. Another thing I will say is we're using the application properties files for things that would be considered secrets, right? Like the password to the database. This is just something I'm doing now. I haven't actually looked into using environment variables and things like that on Beanstalk. I intend on looking at that next, but if you do want to see a video on managing your web application secrets and more security procedures, just like and comment and let me know, and I'll make another video. So thank you, and have a good day.